Alright, well, welcome to another update. I know it's been a while. You might expect that there would be a ton done at this point, and you may not see an immediate difference, but I've got everything moved, and I've made some huge overhauls internally on everything. So let's just go ahead and we'll jump in and see where we're at. I've got everything moved from my desk to over here. I had to get something a bit more permanent. I actually have these mounted to my desk, so that way they're good and out of the way. Now, the biggest thing that I've done since the last update, like I was talking about, I wanted to get rid of the Arduino. So as you can tell, the Arduino is no longer a part of the circuitry. So this whole thing now is flying solo. This is a 100% Palmer Wilson build here now. When I did that, I also went ahead and all that multiplexer talk, and so right there is that multiplexer that we had all that talk about. I'm still using the same microprocessor, the ATmega 328, which is right here, and then I've got my sensors still all going right here, and then I've got my LCD still, and I added a speaker since then. And then I changed the type of button I'm using. Still have some work to do on it, but one thing that was kind of a fun little add-on that I've done recently is with the little speaker. At first I just wanted it to beep when you press the button, but I went ahead and added a whole boot up mode that has a nice little tone to it. So we'll take a peek. I'm going to go ahead and I'll explain more about this in a second, but I got the battery right now because I don't have my relays in, so as soon as I turn all of this on, it turns everything on. And as you can tell, this is everything that runs over, around, and then comes over to the actual cooling elements. So there's quite a bit of stuff going on here now, but it looks a lot better. I've cleaned up a lot of the cables. As you can tell, I've done the proper wrapping and soldering on everything, so everything looks a lot better and a lot cleaner, a lot safer. So anyway, so let's get a quick little power on the bus real quick so we can take a peek or take a listen to what we got going on here. So we'll just plug that guy in here, and here we go. There you go. And so it boots up, makes a nice little sound, and then when you hit the button, it'll do the same. It'll make a beep when it's going through the menus. So that out of the way. Now what I've done here is, because now this thing has a power bus on it. Obviously, since it's from scratch now, I need to build my own power bus. So that's what all of this is over here. This is a 5-volt power bus with some capacitors on both sides of the voltage regulator. It's a 5-volt regulator, and then just an LED for the bus, so that way you can tell if you have power on the bus or not. And then again, standard reset switch for the ATmega. And then this little silver thing right here is actually a crystal, a 16 megahertz crystal. So that talk about me saying that the processor, or that this thing runs at 16 megahertz, that's what sets that, is that crystal. And so I'm looking into that data sheet a little bit further. I found that these things are actually rated up to 20 megahertz. So if I wanted to, I could replace the 16 megahertz crystal with a 20 megahertz one. And that would give me 4 million more instruction sets per second. But everything seems to be working fine with 16 million. So everything's still the same with the current sensors, voltage meters, thermostats are coming out over here. They're over here now. One's up here, one's down inside of here, and then this is just another one for calibration that goes to this. And that's pretty much where we're at on that. Before I fire it up, I'm still working on a couple of things. I got a metal copper plate because I'm going to need to expand the surface area of the top to get the cold area. I need more surface area for the cold side. So I got a copper plate, but I think I overdid it. This is actually a pretty heavy piece of copper, and I can get it cold when I set it up on here, but I think it's too much copper. I either need to get a thinner piece of copper, or I need to get a better heat dissipation system, because I can get this to just below 0 Celsius, but that's not cold enough. But I mean, it's kind of impressive. This is a pretty heavy piece of metal, and I can get that whole thing down to almost 0 degrees. So on top of what's going to happen is it'll be about this size, and then that's what this is this is how this stuff's actually going to mount. I've got an aluminum case coming to put all of this stuff in, and this is going to mount just like that. It'll be upside down. You can think of it like this, and this is going to be the top of that, which will sit in that case. So for the cooling, I'm still working some bugs out on this, but I'm going to go with a liquid cooling system. So this is actually what I'm going to use to transfer. This will be mounted. Those Peltier elements will be sitting between this and between that. And this actually has a pump and a radiator. And so the radiator will be mounted on the back. And I'll have this 2 fans like that, and I'll have the radiator sandwiched between the fans, and that should help me dissipate the heat quicker. And the faster I do that, the lower I'm going to be able to get that temperature, and I should be able to offset a little bit of the temperature rise for having a bigger piece of metal. But I'm still working on some kinks with that. Just so you know, this doesn't just always work perfect right away. Lots of debugging and troubleshooting and trial and error that I'm doing while I'm doing this. I usually end up recording what works, so keep that in mind, that I usually, for every success, there's usually about 5 or 10 failures. But let's just go ahead and power it up and see where we're at. So it comes on. You can see that that power bus has got a green light on it now. So the green lights on both the power supplies. The sensors need to be further calibrated, but still got the amp sensors running. You can see the temperature's dropping really fast, so it's going. So you know that's working. Voltage. The watts aren't actually a sensor. The watts are a calculated value at this point. I have the volts and I have the amps, so I just haven't put that in the new code for this. So it's cruising, doing pretty good. But that's where we're at. You can tell it's already starting to ice over since I just turned it on just now, so it gets cold really quick. Fans are cruising. So it's doing pretty good. So we'll go ahead and kill the power on that. I can't wait till these relays get here and I can just turn that on with this button. So another thing that's taking so long is, as I'm doing this, for one, I've had to completely rewrite the code because I put that multiplexer on there, so my hardware addresses and everything changed. So I just went ahead and scratched the first compiler code and started again from scratch. And because the multiplexer's in there, that doesn't make it harder, it just makes it where there's a lot more to track. So you have to be very organized when you do this. So I have it broken down and I cleaned it up. This is where you can see that where I was talking about writing 1s and 0s to the multiplexer, so you can set the analog pin that you want to look at. That's exactly what this is right here. So it's 3 pins, and all I do is just turn them on or off, and then that tells me which sensor I'm looking at. And these are functions based off of which sensor I am looking at. So these are just a list of the functions that are going, you know, for the temperatures and the currents and the amps. And then there's some stuff in here about the tones for the little music and sound that comes on. And then it goes in, this is the preboot, and then this is the main loop. And then through the main loop, it's more of just a menu display. So it just says which menu are you on, and then it's like, okay, well, I guess I'll dump the temperature if that's what you're on. It comes up here, jumps into the menu with like temperature functions, and then displays it on the screen. So it's definitely getting kind of lengthy, as you can tell. But so that was rewritten. Everything's going real smooth with that. But the other part is, as I'm doing this, I'm wiring in the breadboard, and because I'm not using the Arduino board anymore, that means I get to make my own custom board completely for this project. So I write the code in, I'll wire it in, make sure everything's working, and then after I know that it works, I'm drawing the schematic at the same time. So I'll run a wire, I'll write the code for it, upload the code to the prototype, and then if it's working, I know that it's good, then I'll come in here and I'll draw the pins in. So there's a lot of stuff. This is the AT Mega. Here's the power bus over here. These are pins for the power supply, or these are jacks, so this will be stuff that you plug the board in, plug into the board connectors. And that's what all of these are. These are all the LCD pins that are going out. There's the multiplexer, so you can tell it's definitely getting heavily utilized now. Then these over here are the contact currents and the draw currents, menu buttons, voltages for the contact and the draw. And then this is a 4-pin that's got both of the thermostats on it. So that's where that's at. You can see the speakers on there too now. And then there's also that potentiometer for the contrast for the LCD. So this is important because as I'm doing this in this software, it's allowing me, I add these, but I also, when I add them, I'm very specific about the models of everything that I'm doing, the actual manufactured pieces, because those are in the libraries in this software. So that actually has the dimensional, definitions of what this stuff looks like. So this is where I'm at right now. Everything that I've written on there, this is what my board is going to look like after I've finished it. Well, it won't look just like that. This is the actual what I'll use to transfer the image. Because then, if you've seen any of my my other little board projects, I've got boards that I make like these, and I can make them relatively easily. So this size right here is the size of this square. So I'm fitting everything. All of this stuff is going to fit onto this board, and it'll be 2-layered. It'll be 2 sides. That's why there's 2 different colors there. But this is one of the more exciting parts of the projects, is once you get to where everything is working and wired in, then you actually get to make a board. And so we're getting closer. I've still got a couple of sensors. I have the alcohol sensor to put in still. I have a second button to put in. I've got a relay to put in, and I have the pump to put in still. So there's still a little bit of space left. Looks like I should have plenty of room to do all of that, and then we'll get to where I'll actually show the process of where I'm going to make this board. So I know that's kind of a lengthy update, but that's where everything is at right now. Again, super proud about taking the training wheels off, and I'm not using an Arduino board anymore to make all of this work. So there you go.